What's up, everybody? Welcome to the Artist of Data Science Happy Hour number 56. I believe this is 56 happy hours in a row, man. We've been out here just dishing out wonderful information and helping people out. Shout out to everybody in the room. Christian is back. Good to see you again, Christian. Good to see you indeed. Eric, what's going on with the 3D glasses? Man, is in the building. Gina, good to see you. Monica Royal is in the building too. Hopefully, you guys had a good week. Hopefully got a chance to tune into the episode I released today with the one and only legendary Andy Hunt. He is co-author of The Pragmatic Programmer and many other books as well. I've been going live a lot. This week I went live with Danny Ma yesterday. So that was a lot of fun. I went live with another legendary person, an Oxford professor, Marcus Du Sautoy. He's written the Creativity Code, Music of the Primes. He's written this. The newest book is called Thinking Better. So I had a great opportunity to chat with him. We talked a lot about just kind of his philosophy of mathematics and what he loves about mathematics and creativity and things like that. It was a really great conversation. I really enjoyed it. He was also kind enough to introduce me to Dr. David Spiegelhalter. So hopefully I can get Dr. David Spiegelhalter on the show. He wrote the book, The Art of Statistics, How to Learn from Data. He's that's right, Cambridge. Look at this shit. Look at me, kid from the street, Sacramento, California, from the hood. And I'm talking with Oxford professors. Like that's mind-boggling, man. That's pretty cool. What else did I do? I spoke to Dalian and Lou this week. We did not go live though. We just chatted a little bit, and that will be released at some point in the future. So looking forward to releasing that for y'all. And yeah, man. Hopefully you guys are excited for the weekend, man. It's this entire month. I counted. I was live over 20 times. Over 20 times, including presenting at Datacated, presenting at ODSC twice, and the house list at Comet. It's been going live, man. It's been one hell of a month. Hope you guys are excited for Halloween. I, for one, am indifferent to that. But I like seeing little cute kids in their costumes. So that'll be a lot of fun. And, we're going to dress my son up like a cow. Sounds crazy, man. I went to go try to put him to bed earlier today, and he was just screaming. I had to drive over to the in-laws' house to try to put him to sleep, and he screamed so much that he vomited. And he vomited all over me. That kid is insane. Say kids they have. It'll be fun. It's not. I know it is. It's awesome. I love that kid. But yes, hopefully you guys are excited to be here. If you have questions, go ahead. Let me know. Drop your questions in the chat. I see you all enjoying on LinkedIn and on YouTube. So I want to kick this thing off. I made a post just a little bit earlier today, a couple hours ago. Just thought I might trigger some people and kick off a discussion. And that post was, data engineering is the most important part of data science. I want to get your reactions to that statement. I used a meme, taking a page out of Danny's book. I used that, what's it? Change my mind meme. So yeah. So is data engineering the most important part of data science? I would love to hear what you guys think. Let's start with Christian, man. It's been a while since we heard from you, and then we can go to Eric, and then Matt Blaza is in the building. And if you guys got questions on anything whatsoever, please do let me know. If you guys got questions, I will gladly take them. Christian, go for it.
Yeah, no, I saw that post right before I jumped in, and honestly, that'll be a good discussion right there. I'm actually interested to hear from folks who are sitting in the seat right now doing it, and interested to hear from Eric and some of these other guys on whether or not that's true. I mean, from my standpoint, there's one thing that I've heard several times, and it's like, hey, if you are just doing stuff standalone in Python notebooks with clean, curated data sets, you haven't gotten down to the arena yet, right? So being able to have that data at your fingertips seems pretty crucial. So I'm looking forward to hearing answers. Eric, you're in the battlefield. What do you think?
Eric, let's hear from you.
Yeah. So my first thought was, oh heck yeah! Like I'm grateful every day that I'm not a data engineer, but I'm also grateful every day that someone is, because it's work that I personally, I don't get jazzed about it. Sometimes I get jazzed about little pieces of it. But then I think I'm going to read about data engineering, and I get one paragraph into a blog post and I'm falling asleep. So it's just not I just don't get excited about it, but I know it's super important because anytime I want to like make a cool change or something in my work, it comes down to some pipeline somewhere needs to be adjusted. And
Mhm.
so I know it's super important. On the other hand, though, as I tried to think about whether or not it's really the foundation, I think that you can kind of quote unquote, you can outsource some data engineering on a small scale because a few months ago, my partner and I were working on a small project for like a nonprofit, and they're small. They're not big. They don't have a data engineer. They only have like 2 employees, right? But they have various services and things like that that they're subscribed to, and we're able to bring data together manually from different sources to get real business results, like make change, but we didn't necessarily need a data engineer in order to facilitate any of that happening. So I just think that it's just like, I think it's just with scale, it does really become foundational. But if you're doing something on a small scale, never underestimate the power of, you know, one person with willpower and, enough time to figure it out.
Eric, thank you so much. Let's go to Monica, and then after Monica, we'll go to Matt Blaza.
First of all, I just want to say that I think I'm way too overly excited for Halloween.
I love it. I absolutely love it. Is that you gotta break this down for us? I don't immediately get that. Is that Albert Einstein?
So I'm a data scientist.
A mad scientist. I love
Not
it. I love
creative,
it.
but also like the most dressed up, I think. So I was like, should I turn on my camera?
I
I
love
was
it.
afraid I was
love
going to
it.
be underdressed, so I'm glad that somebody dressed up. Thanks, Mom.
Always. This is my favorite holiday. Okay.
That's awesome. That's awesome. I dressed up as a 90s grunge kid.
Nice. I love it. um, completely agree with everything Eric said. Very much important when you're scaling. If you're in a small environment where you can directly connect to a database and write some SQL queries to pull your own data, then I've done that in the past where I'm very much, beginning to end through the process. But in my newest role, we have dedicated data engineers, and I'm finding it very fascinating and very grateful for them to be able to do that work for us. And without data, I mean, where would we be? So yeah, they're very, very important.
Absolutely love that. Matt, are you still there? Yes, you are. Matt, go for it. 1.21 data watts. I love that. Future
Yeah,
reference.
no, yeah, no, like I mean, for data engineering is super, super important. I just spent all the time before just playing around with just Python saying, okay, I'm just gonna create a model and that's it. But the more I've like worked with data engineers over the last three years or so, I'm starting to find out, hey, you need to know it's garbage in, garbage out. I mean, if you don't have that data engineer working on that pipeline, you don't know if the inputs that you're putting into that machine learning model are actually even are even accurate. So they have to make sure that the pipeline's processing. They have to make sure that the lineage is correct, because not every data that you're pulling in from one table is the original data. That data in that table could be pulled from like 3 other tables. And usually, even as a data governance analyst, you still have to ask them, they know better than you what transformations are going through and what exactly how that's being anonymized, because there's batching and all this other stuff that's even being done in the pipeline. So it's very important that data engineering is there. And if you can, I mean, you need to at least have a sense of it to be able to communicate with them, which is why I still do my own pipelines on the side, so I can communicate with them and know what they're talking about. And they don't look at me with the question mark on their face.
Yeah. Thanks, Matt. Yeah, definitely want to hear from Christian as well. Before we get there, though, like this is kind of my standpoint. I feel like as data scientists, as people who are actually building the models and stuff like that, we're actually downstream consumers of data. So we use data. So it's highly imperative for us that we have there's the real world, and we capture information in the real world in the form of data. That data goes through transformations, but that there needs to be quality checks in place for the data. We need to be able to ensure that it's what we expect, and not only that, those data pipelines need to be robust enough to handle a wide variety of situations. Yeah, data engineering is I think I came to this realization after just working with curated data sets for the last like couple weeks, just because now I just do machine learning all day, just building models. But Christian, let's hear from you.
I was just listening to this, and I totally agree with the importance of having that data stream and everything. But I guess I was wondering, at the risk of being overly pedantic, the most important part. I'm a business guy, maybe more strategic minded. Do you think it would actually be, or maybe this is what I'm saying is where I stand, is maybe it's actually the strategic and outcome orientation of step one of why and what levers are we pulling? Otherwise, I might have the greatest data and I might have the greatest data scientist, but who gives a crap because I'm solving the wrong problem?
Yeah, I mean, but if I would have said that, I wouldn't have triggered anyone. They would just
Right. That's overly pedantic, but maybe that's where I stand.
No, it's absolutely true, though, man. Absolutely true. Marina, I would love to hear from you. I guess I don't know if you've missed the question, but I was just making a statement, trying to trigger people and trying to get a conversation going that data engineering is the most important part of data science. I would love to get your input on that. By the way, everybody in the chat, everybody watching YouTube, LinkedIn, if you guys have questions, please do let me know. I will add you to the queue.
Come again? What was the question? Yeah, I just joined.
Yeah, a question was that I just wanted to get people's reaction to the statement that I made, which is data engineering is the most important part of data science.
I may have to agree with that. I think there is a meme, that has, I don't even know the name in English, like about data lake, and I think data scientists, we are on, we ride on top of data engineering. If that pipeline is not in place, it's not, it's just this very, very hard to do any good work. You always have to check with them, right? But again, like what Christian said, I agree. You have to have the right question to answer. Like, everything has to be accordingly to the outcome that you need in terms of like a product or a business. Or I totally agree with that. But I think data engineering is, I was trying to not say anything. No, we are the best. No, I think that. I think data engineering is extremely relevant. Sometimes we take it for granted.
Yeah, absolutely. Yeah. Russell, I would love to hear from you, and then after Russell, we'll go to Manny after that. I'm not sure if Russell's camera is frozen. Nope.
I think I'm on. Can you hear me?
Yeah.
Just, can you remind me of the question? I've been dropping in and out. I don't know if you've noticed. I just put a message in the chat saying the gremlins seem to be attacking my system. So remind me if you wouldn't mind.
No, it's just getting people to react to just this, my attempt at triggering people with a meme, just saying data engineering is the most important part of data science. I just want to get people's thoughts and opinions on that.
Sure. Well, if we take the data out of the equation, engineering and science are two very compatible fields of very necessary disciplines for human progress. So, you can't have a good engineer without science, and engineering very often helps sciences, especially some of the deep sciences, say, I'm trying to think of a deep one now, but say that, a quantum physicist or so, something like that, is going to need to be able to implement some engineering principles in their science. So in that very broad spectrum, throw everything in a pot to try and understand the two descriptions, I'd say, personally, me, I'm neither a data scientist or a data engineer. I'm a little bit of both and a little bit of a lot of other things as well. So I suppose that maybe the sitting on the fence answer, or the more objective answer rather than subjective, is neither and both in varying degrees depending on the job you're actually doing at the time. So some days I'll do things that I could classify more as data science. Some days it'll be more data engineer. So yeah, I'm trying my best not to be triggered, if you can tell.
I can tell. I like the very politician-like answer. Manny, let's hear from you.
Hey guys, can you hear me?
Yep.
Yeah, I think my thoughts are come more from a business sense, right? Kind of like Christian, piggybacking off of Christian, and in a lot of organizations that I work with, they can't even have a data scientist. What they really need is a data engineer. That's just frankly how what the business needs, right? That they need to be able to access data, and maybe they don't need the fancy data science models. Maybe what they need is, well, I just need this view and this visual, right? So they need to get all these sources together. So I think we're trying. This is a data science podcast, but it really goes to what does the business need? What are we trying to solve? What problem or business problem are we trying to solve? And sometimes it may not be a data science problem. So that's why I think data engineering, in some sense, is kind of like the foundation for everything, especially if you're trying to go into analytics. And as everybody else was mentioning, data science builds on top of that.
Yeah. I'm kind of liberal with my use of the term data science. I consider like data science to be like an umbrella. So there's like the traditional data scientist, data engineer, analytics engineer, BI people, data analysts. All these people kind of fall into that data science umbrella. But yeah, I'm ready to take some questions. If you guys got any questions, please do let me know. I'd be happy to take some of these questions on. Oh, dude, by the way, Facebook changed their name to Meta, huh? That's some. I mean, Ron Artest should say something. I don't know if you all know who Ron Artest is, basketball player who changed his name in the mid 2000s to Meta World Peace. I think he has the rights to that. But yeah, anyways, what the companies are no longer Fang, but it will be I guess Mang or Manga. Interesting. Marina, let's go. Let's hear from you.
I have a question about visualizations. So what kind of visualization tool is like everybody using? And probably if you will have to learn one, or you wanted to use one outside work, because that may be a different one. Like which one you will recommend? Like Locker, I don't know, like Tableau, or that's my question.
Yeah, I'd love to hear from anyone who has expertise on this. I don't do a lot of visualizations, just matplotlib, but go for it, Christian.
So that's how personally, that's how I got started in the data world. Is I got introduced to Tableau and Power BI and all that kind of stuff. I found if you can, just like with anything, is you kind of learn the lay of the software, right? Tableau's super simple and super applicable, and with Tableau Prep also, like, it helps you to do some basic repeatable cleaning, right? And so that's what we deployed when at a larger company I used to work for, when we kind of spun up an analysis group across functions. We had a lot of data and information that we were able to acquire ourselves, but didn't have a great way to like present it to folks. Tableau is great because you drag and drop it in there, you create all these views, interactive, and you can publish it to server as well. And so stakeholders can interact with it now. And so I had a really, really good experience with Tableau. There's some things that Power BI does that Tableau doesn't, but I'm still a Tableau fanboy. So if anybody asks and they're looking to get started, I recommend Tableau myself.
Matt Plaza, go for it.
Yeah, I mean, if it's just for like building out your own visualizations on the side, Tableau, I agree with Christian, is really very, very useful for that. If you're working like with something more like Azure, or you have an Azure environment, or like a server like there, Power BI I found is a lot more easy to configure to, get insights for that and to connect to the data than Tableau is.
Anybody else have any insights on this? I want Ben Taylor's in the house, by the way. Ben Taylor's going on, man. Good to see you. Like that beanie there, toque. That's what we call it in Canada. Russell, go for it.
So I just wrote something very quickly in the chat there, saying trying to decide the best visualization or BI tool. It's like trying to decide the best dessert, your favorite dessert. A Michelin-starred chef is going to be able to create something fantastic that not very many people at home could do. But your average cook at home might have a really good cheesecake recipe, or a chocolate cake recipe that many people can do. And I think it's kind of like that. If you are a Michelin-starred chef level of data, let's say broad data, not just data science engineering, but any kind of analytical approach to data, you're very possibly going to have the skills to use, ggplot, matplotlib, all of those kinds of things. But the more approachable ones, such as Tableau, Power BI, etc., are great for I don't want to use the word novices, but the lower level echelons of that data expertise, especially Power BI. It's part of the Office 365 environment, so it connects with so many things. You can run it standalone. You can run it on an enterprise level. You can connect it to Azure SQL, etc. So there's a lot of room for expansion for that. However, it's tied into the Microsoft environment. Tableau standalone, also very good in its own right, a little less flexible than Power BI. So it kind of depends on the environment in which you're using it, the skill base of the users. And when I say the users, I would draw clear distinctions about the user developers and the user consumers. So both of those, you will publish something, the users will come in, they will interact with it via the the slices, the filters, flicking between pages, etc. And there's slightly different usage characteristics between the two. And then your developers as well will create and maintain all of the stuff that you publish. So there's I'd say kind of a curved scale. Your entry level things, and as we say, Power BI, Tableau, there are others, Click, and a whole host of others that I can't remember off the top of my head. But those are a great entry-level tool, but don't restrict yourself to using those simply because you start with those. They should not restrict and allow you to grow and build upon those as part of a wider visualization structure.
Thank you very much, Russell. Anybody else have any suggestions? Marina, did that help at all? Like, are any of these things free? Like, I know Tableau has a free public tier, but I don't know about the rest of these things. Like, is there anything that's just available?
Power BI is free, but I find it's a little bit of a frustrating licensing model. So it's free for everybody. You can download the desktop and you can do whatever you want. However, you cannot see the product of anybody else unless you pay for a paid license. And the first paid license, I think, is a pro license. I think it's $9.99 per user per month. So you can't see others' work until you have a pro license. It's kind of a reverse paid structure. It's almost, I've had this conversation with a few other people. It's a bit like a kind of a drug pusher, give you the product for free, let you play around with it, get deep into it, really enjoy it. Then when you want to share your work, you have to actually ask other people to pay for a license so they can see your work and vice versa. So there's benefits to it, but there's also distinct restrictions to it. And Tableau, I think, is the other way around. So there's different license tiers to it. There's kind of a basic user, which is low in the midst of what Power BI low license is. And there's a developer license and the server hosting modules that also change much as they do with Power BI.
Grew up around a lot of drug dealers, so I can say that strategy does actually work. Gina had a question that came in before Christian, so let's go to Gina's question, then we'll go to Christian's question. Gina, you had a question about deploying models. I think Ben Taylor or Joe Reese would I'd love to hear you guys' perspective on this, so keep an ear out for the question here.
Great, thanks. Hi everyone, good to see everybody. So my question is around, and for those of you who I haven't interacted with on the happy hour yet, I've been through a data science boot camp. I also have many, many years professional experience, including some analytics, financial modeling, investment analysis, and a whole bunch of other things. So I'm coming at it with a career pivot. And I'm continuing to build my skills after the boot camp. And so I'm aware of some tools to deploy models or even just little software scripts in online. And so like I'm an avid cyclist, but particularly on Zwift indoors. And I joined a racing team, which is kind of funny. I'm going for last place because I'm racing above my level. But somebody came up with the idea they want to be able to post in Discord. They want to be able to post their kind of workout graphs from the workout, but they want it to look like a Zwift graph. Just ease of comparison. You see it at a glance. You know where people were in their workout zones. And so somebody started some code, and I'm like, ooh, I'm going to take this. And I built on it and added some stuff. And now I'm thinking of putting up in Streamlit. So that's a very, very simple example. That's not a data science thing per se. But one of the things they didn't really go into in the boot camp, and I really wish they had, was, deploying models with, Flask or REST, and like I'm already kind of out of my element. So I'd really like to get your guys' input. I know for a lot of you, this is like probably super basic in entry level stuff, but I'd really appreciate your thoughts. Because as I continue to build on my portfolio, this is an area where, it'd be great to understand some of the better places to go with it.
Yeah, definitely. I mean, dude, you'd be surprised. Like, in a lot of companies, deploying is not fancy. It's just, sometimes saving solutions off as a CSV, pushing them into a database. Some people get sophisticated, have a web API if they want to be more advanced. But Ben, Taylor, let's go to you.
Yeah, if it's a personal project, Flask is great. So Gina, if you look into Flask, I think you will be delighted how simple it is. To start, I'd recommend looking, I think the classic is like the chat server. So you have like a chat server example, then you'll realize like, oh, so when I ask a question, when I send something in, I'm going to have a model loaded in memory and I'll kick back a prediction. And I think you'll find lots of Flask sklearn examples. But I think if you look into it, you'll be delighted that like, oh, this is super easy. For anything that is being consumed in production for a company, there's issues on scalability, SLAs, there's consequences. And so the list of consequences quickly grows. It's not just about the model going down and scalability issues. It's also stuff like feature drift. So when I was at HireVue, we had a feature drift excursion that impacted the customer, which surprised us because the models are static. So the model's static, customer's happy, first month, second month, third month, everything's great. And then suddenly within 24 hours, it's hair on fire. The model's not working at all. And the root cause, it doesn't matter how good your data governance is. The root cause is a vendor that doesn't have as good of data governance as you, especially when you get into these really wide models where you're consuming stuff from other people outside of your circle. They had shifted a threshold without telling us, thinking it was minor, and it had impacted something in the model. So, so when it comes to production where things are consumed, I think there's a very long list of problems. But I'm curious, like I'm sure there's people on this call that have started with the put a Flask wrapper API around your machine learning model and then respond to scalability. Like you can throw machine learning models on Lambdas on Amazon, you'll get really good scalability. And then maybe something I'm more naive to is you do have SageMaker and different things that can scale models, but I think it's still a little bit more, I have a bias because I work at Data Robot. I'd say it's still more of like the hobbyist level when it comes to like, oh, you get fired for a prediction gone bad, then I would lean towards my employer for stuff like that. Or I'm curious, Joe, are we competitors?
Just
if we are, that's
you'll be fine. Ben, you can Venmo me money after. I'm just joking.
Yeah, here it comes.
Okay. I think that those are all good points, really. And I think for where you are right now, focusing on, I think, showing that you know how to deploy a model is the most important thing. The other things I would say you should know about too is just how does REST work? I think that's an understated skill, and this sort of starts getting into software engineering. But when you're deploying stuff to production, I don't think you can ignore software engineering, and so know about like also other things like serializing and deserializing data. Right, like that's pretty key, and just the basic concepts of like REST, like get, put, post, delete requests, and that kind of stuff. I think they're just awesome things to know in general. Like it'd be one thing to know how to, I think, going through a tutorial and deploying Flask, but then like, why does it do what it does? I think those are where you are. I think those are the more important questions I would say like you should be looking at, because like as Ben points out, once you get into production, there's no shortage of myriad ways that things can go wrong. And also knowing like basic stuff like if my API is broken, like where that tends to be understated quite a bit. So that's where I would personally also look. But I think what Ben suggested is great, and just go use Data Robot for everything.
Would you say there's kind of a hierarchy? You kind of alluded to it, right? I mean, right now I'm talking Streamlit, and a guy who is also in my program is using Streamlit on a very basic predict the grade level of elementary school students, predict their grade level based on the essay. And literally, it's like you upload the text in there and then it makes those predictions. So, but it sounds like, you have Streamlit, you have Flask. I don't know where REST falls into that because
that's why I'm saying like learn what REST is, because it's not, because I think like Streamlit and Flask sort of obfuscate a lot of these details. Like REST is really a paradigm. It stands for representational state transfer. Sorry, I'm talking for days now. And really that's a paradigm, of it's a way of, but not just serving data, but it's a request and response model of data, right? And so that's what I'm saying. Like Flask is just it's an abstraction built on top of, and actually Flask itself is a web server and a web framework. There's actually Flask REST for the API part, right? And then there's also new APIs like Fast API, which I think is dope. But if you don't really know like REST and kind of how the request response model works in web servers, like that's where I would say like start there, because once you know that, then it's kind of like any API is an API at the end of the day. So.
And then where does it go from there? You mentioned Data Robot, which is up here somewhere. You mentioned Lambda on AWS, and you said even with that, that's not necessarily at a level you would want to be when, your job's kind of on the line really day to day.
There's so many options.
Just a lot of options.
Yeah.
It's part of the problem, right? I think most of the discussion is just like trying to like cut through like what is a tool versus what's a paradigm.
Yeah.
Right? Like Lambda has this notion of serverless. Now you got to figure out what that is.
I did a webinar this week where we're showing predictions in Java, in Snowflake. So like natively in Snowflake, you can upload Java user-defined functions, and then right there in SQL, you're doing your machine learning models, which is pretty awesome. So then there's no server. Snowflake took care of it, right?
I was speaking with someone this week who has actually been at a company for like over 10 years. They've been doing modeling. The company has some patents actually in, I think, some machine learning stuff going way back. And he was talking about, they use Google BigQuery, I think, and they tried Snowflake for a while, and then they actually, I think it just didn't work very well for their use cases. So it seems like now you're talking Google BigQuery. That's getting into those higher, kind of more heavy duty approaches to deploying models. He's a data engineer and has been for many years, so he knows his stuff.
Yeah, and that's another one. That's a data warehouse. It's serverless, and right? So you can see it's kind of like turtles all the way down. And the other thing I forgot to mention too, if you're dealing with an API, then you need to know how networking works. If you're going to do that in production, you better damn well know how networking and security works. You're not going to just have like some unencrypted the thing about authorization. You'd be crazy and you get fired. So there's a lot to know. So I'd say like, it's interesting. And that's where I think Ben is sort of alluding to as well with these tools that sort of, allow you to work in production. Because if you were to try and do all this stuff by hand, this is where I've seen a lot of data scientists. They're like, oh yeah, I'll just do this model in production in Flask. And it's like, cool. Do you know what that actually requires in production? It's not just like firing up on your laptop and on localhost. It's there's a lot to it.
Thank you for mentioning, Joe, about REST and making that distinction that it's a paradigm, and really understanding REST, it sounds like, will help a lot just conceptually and, more tactically understand how stuff is actually, the what is happening under the hood, if that's accurate to say, in deployment, and learning some of these things at kind of a fundamental level.
Yeah, good luck.
Thanks.
Right on. Gina, great question. Great discussion here. Let's go to Christian's question. Yeah, Christian, go for it.
Yeah, sure. Well, it's, there's for the last 10 years, it seems like it's been a lot of questions about resources for learning skills, and it's always going to be important to stay sharp. But I'm just wondering for the folks here, like, what are the best resources that you might recommend or that you've come across for maybe data scientists specifically to get more effective at things like identifying high value use cases and informing and influencing stakeholders?
Vin Vashista's newsletter. That's for sure. His newsletter is amazing. Mostly newsletters. That's story go to. There's another guy that I found on Twitter. His name is Santiago. I think if you type in like Santiago machine learning or Santiago just data scientist, he might come up on Twitter. His stuff is pretty good as well. But yeah, I'd love to hear from, I mean, for anyone really. Like I think Eric dropped off, but Monica, how do you stay sharp? Matt, how do you stay sharp?
For more strategic level stuff, I tend to look into like the methodologies that you're using. So within cybersecurity, there's that NIST 853 type stuff, and to just look at that high level. I can't think of anything beyond like those high level methodologies.
How about let's hear from Ben or Joe on this, because you guys been in the game for a while doing this stuff. OG days. How you guys keeping on top of things?
Christian, you're talking about influencing key stakeholders for your.
Sure, yeah, like from a data scientist perspective, especially like if you're always talking about you want to be outcome oriented, you want to hit the big wins, especially let's say you're early on in a data science org, you want the quick wins. How do you identify the high value use cases? And then kind of along with that is like, now you got to influence people that these are the right things to do.
Yeah, no, I love this question because I really sucked at this. Because we all love data science, we're so excited, and I remember having like an hour-long meeting with an executive and showing them the 3 things I tried, and now the third one is working so well, and they don't understand any of it. And I'm thinking like the whole time they're wondering like, how much are we paying you? Should we fire you? So the best way to do it is there's some good exploratory questions. So it's good for you to know what are your top KPIs this this quarter, because how are they getting bonused out? Like if you can help them next quarter, they're really going to like you. So what are your top KPIs? And then if you want to be more exploratory, you can say, what are the numbers in your department where a small change in that number makes you really excited? And then they're going to talk about, oh, we've got loss, or they'll bring up some numbers, and those could be opportunities for AI improvements. And then the other thing I like to say is, where's your growth bottlenecked by human capital? So if I could gift you 1,000 humans, they're experts. It's only one job family. What are they? And they're free. They're free for a year. Where are you going to put them in your department? And so that allows you to kind of shine a light on potential problems. But the more you start working backwards, the best thing you can show an executive is a number with a dollar sign. And that confuses data scientists because we're so analytical, we're so fact-based. But the reality is you can go through a utility function and come up with all these assumptions. So if you have a predictive model and you do some kind of cut or something, you can back that into, I'm estimating I'll save you $10 million a year. And if I disagree with you and say, I think you're full of it, now you can go through your assumptions and we can have a discussion. So the more you work backwards, never use any jargon, never show your work, just show the outcomes, that you'll do really well. I did not know that originally.
But Ben's still very successful. So
I've had my ass kicked enough. But you really do win on the quarter. So if you can guarantee, like everyone you interact with, how are you going to get them promoted next quarter? With that mindset, you will be working on the right problems. Obviously, you want long-term strategy, but you can't do long-term strategy if you don't have short-term wins first. Get the short-term wins, then you can be more expansive.
Thank you very much, Ben. Joe, love to hear from you on this. And then after that, we'll go to Gina.
Yeah, I mean, it's it's very much like a sales question, right? But I think that's what most things end up just becoming. It's sales and marketing at the end of the day. So, yeah, I mean, Ben's right. Start with kind of the problem at hand. Like I was on 3 or 4 sales calls today, right? I don't think once did I ever use jargon. And we're talking about stakeholders, some technical, some not. And the thing I was focused on was like, what are you trying to do? And how can I help you? That's it. Right. At the end of the day, when I asked a really wealthy friend how you make a lot of money, he said, well, you just sell what people want to buy. It's easy. Yeah. It's that easy and that hard, but really that's no different when you're trying to, sell a project internally or something, right? You just figure out what motivates the person and what they value and sell them that. You don't need to and in fact, it almost talking too much works against you in a lot of ways. That same guy also told me when they're about to buy, just shut up and take the sale. Stop talking. So that's the other thing, because data scientists, you will all be tempted to just talk a lot, like I am right now. but
48 laws of power. Law number 4, always say less than necessary. When you are trying to impress people with words, the more you say, the more common you appear and less in control. Gina, go for it.
Ouch. Now I'm going to say something right after that. Oh my God. And it's so true. And I've worked on it for years and I'm still working. Incentives. It's all about the incentives that your executives, your managers are facing. And that's not to say they'll always be rational. I've heard of situations where the data scientist does this analysis, they try their best to explain it, and it goes against the executive's intuition. I won't go into the specific case, but it can be crazy sometimes. So, I mean, there's only so much you can do. But like Joe says, like Ben says, and this is where having lots of years of experience prior, in a range of environments, including consulting, it's the bottom line. Why do they care? Why should they care? What matters to them? They don't care about fancy statistics or cool models. I mean, if they're not technical, they're not going to care about any of that, as long as they know that there's something behind it and you're not just making crap up. It's really important. And so years ago, before I was doing data science stuff, I was working in a role that was worldwide team in a great big company, no P&L. So you have to try to earn your keep somehow. And we were working with 2 different groups, trying to convince the technology solutions group, the people who would actually go out and repair PCs and repair servers and this and that, to push some of that out, let more of that be handled by channel partners. But they didn't want to do that. They kind of wanted to own all the customers. And this is a problem from a market share perspective, especially in certain countries, because they're getting their lunch, they're getting their butts handed to them in certain countries by other big hardware manufacturers at the time. And so what we did was, and I came at it with I'm agnostic, I'm going to go out and get information from people. And we talked to a lot of salespeople in different regions, and they kept coming back saying, yeah, this other big storage company, kicked our butts. I lost $6 million sale here. I lost 10 million there, because for the small and medium business customers, they were fine with letting channel partners handle it, and our company wasn't. And this was extremely contentious. And yet we managed to, with the analysis I did with the help of some others, we managed to convince the senior management in that group that didn't want to give up that channel, managed to convince them to at least give it a try. And that was a big win for our group, because we needed to have credibility, and we needed to show that, even though we were kind of more aligned on the hardware side, we needed to be able to show that this is legit and back it up with analysis. But at the bottom line was, we could be making $40 million more annually. Basically, we're growing the whole pie. So we're making more sales even on the technology support side by giving up some of this stuff to channel partners. And when you can make a case like that, it's pretty hard for anybody to argue with it, even when there are fiefdoms and territorial kind of turf wars going on. So that's the other thought I would, convey on that, is just also understanding those dynamics and establishing trust with the different groups. So you have credibility. They don't think, oh yeah, well, you're just coming from this group and you're just trying to, and in big companies, you can have these tensions sometimes. So I probably talked too much there again, but I hope that
Gina, thank you so much. I appreciate your perspective. Thank you so much. So
I was going to throw in real quick.
Yeah.
Listening to Gina, I think one of the things I'm reminded of, that's why it's important to have a shotgun approach, because if you bet all your eggs on one model and there's some intuitive hiccup or pushback or politics you weren't expecting, have 3 to 5 problems, work with the subject matter experts, have them write the dollar signs next to the problems before you start, because you can get buy-in before you even start. And I think it's funny because you say, what is this worth? And you have shoulder shrugs, then say you can put a 0, $1 sign, or up to $5 signs. And then if they tell that to you, then you're kind of working on the right problem. And that might save you from stubbing the toe on something later.
Christian, hopefully that was helpful. That's a lot of good insight there. Thank you so much, guys. Let's keep it moving. We got a question coming in. Greg Coquillo is chilling in the chat. Before we get to Greg's question, though, shout out to Antonio Ivanovsky. He is watching on LinkedIn. Antonio, they just him and his wife just had a baby a few weeks ago. Congratulations to my friend. Hopefully you got the snoo. Need that thing, man. You're gonna need that. That's the key to sleeping. But congratulations to you, man. It's gonna be a hell of a ride. So we got Greg Coquillo's question coming in. This one's for Ben. And he wants to know, I saw this post that you posted just like as soon as I opened up LinkedIn. It was, what do you think about Elon's idea of a Texas Tech and Science University?
So I'm a little embarrassed about this because it's a joke. So it spells
Oh.
tits. But I'm a huge Elon fan, so I fell for the joke. I feel like anything Elon touches gets disrupted, and so unfortunately it is a joke and it's inappropriate. But if Elon did say, I'm going to make a university, I would fight like hell to get my kids to go there. And I think all the other institutions would be in huge trouble because it takes 5 years on average for an institution, like your traditional institution, to incorporate new curriculum. And for everyone on this Zoom call, how does that set them up for AI and data science? Like it's, they're like failing before they start. And there's a few that are okay. And that's why these boot camps are so appealing because they're much more nimble. So yeah, sorry. I kind of I spread that joke even further.
Ben, I wouldn't say that I wouldn't even put it past him for it not to be. I mean, look at the way that he's named his models for the Tesla. But they're real cars, so he may very well put a university out there with the acronym TITS.
Wait, hold up. Explain that to me. What's his?
So the Model S, the Model 3, which he wanted to be the Model E, the Model X. Sex, right? He really did it. That's what he does. So I wouldn't put it past him to make a university and make that acronym. And I agree with Ben's thoughts. It's like that. I've been in college for way too long, just started another master's program. And some of them are great, but there's a lot of friction, a lot of pain, a lot of just dumb stuff happening in the university system, ripe for disruption. And I would totally, just as Ben was saying, I totally agree.
What a guy, man. Elon Musk. Love that guy, though. Seriously. Greg, there you go. It's a joke. So hopefully your question wasn't serious and you weren't just making fun of Ben. All right. So if anybody else has a question, whether you're on LinkedIn, whether you're in the chat room, let me know. I just want to, ask a question mostly for Joe, because I know I've heard you talk about this before. The switch from ETL to ELT, the use of something like DBT. Like, break this down for data scientists and analytics engineers out there, and what's this shift about? Is it a cultural shift? Is it just do we realize that it's easier to do this? Yeah.
I mean, so the difference really is there's ETL, which is extract, transform, and load, right? And then there's ELT, which is extract, load, and transform. ETL for the longest time has been the predominant paradigm. This is typically used in data warehousing, for example, moving data into data lakes. The idea is with ETL, you're going to extract data from a source system. You're going to transform it in flight, and then you're going to land it maybe into a database table in a destination, right? So extract, transform the data, and then load it. And the reason this came about really, it started because I wouldn't say it was adopted because you had limitations on hardware back in the day. This is predominantly a paradigm used in on-prem systems where you have to buy servers, databases. These are expensive, and you don't have a lot of resources to throw at it, right? So you have to, typically the system doing a transformation, it's going to get bogged down, right? And you don't want to interrupt the downstream database from queries, nor the upstream system from which you're getting data. But you kind of circle around the advent of cloud data warehouses, starting with Redshift. I think the realization was, well, you could just throw your data you could just extract the data from a source system and then load it into a cloud data warehouse, for example, in a staging area, and just that raw data is there. You could use the seemingly infinite compute power, of that cloud data warehouse, and just transform the data there. and just load that into a new table within that data warehouse. I think that was really the fundamental shift. Is what happened was cloud data warehousing, and along with that, to some extent, cloud data lakes. Although I think that it's more of a separate discussion, but we'll stick with data warehousing for now. So that really was the genesis of, I think, the ELT movement. And since then, it's I would say this is becoming more of the predominant paradigm we're seeing. ETL is becoming, I would say, less of something you would do as a net new way of getting data into your data lake or data warehouse. So I hope that makes sense. That's about the 3-minute version of it. So
thank you, man. I appreciate that. Yeah, definitely enough to check out. I think you did like a talk or discussion about this was it Dedicated that you did this talk?
Yeah, the expo. Yeah, the 10-minute lightning talk. Yeah.
So I'm gonna go ahead and check that out as well. Thank you very much. Yeah, just been, I'm always I just want to get into all parts of data science. Like, I just want to know a little bit of everything, just to be well versed as possible. So data engineering has kind of been the thing I've, kind of been poking around and trying to learn more about. All right, let's see if there's any other questions. Shout out to Ken McCabe, found his way into the room. Ken, I realized that I had put the link, a faulty link in the chat, but I'm glad you're here. If you got any questions, let me know.
I appreciate it.
Yeah, no problem. If you got any questions, let us know, man. YouTube or LinkedIn, any questions, please do let us know. All right. No questions coming in. All right, let's where we want to take this. Let's see. All right, this is a host in crisis, just trying to think of something to come up to discuss. Ben, I see you're unmuted. Please save me.
What is next after deep learning?
What is next after deep learning?
Can deep learning take us where we need to go, or does it need a reinvent? Do we need to burn it down on the ground and start over? Curious if anyone
did the physics.
What prompts you to ask that question?
Yeah.
Because I'm obsessed about the singularity in my kitchen.
Yeah. I mean, look, I think it's going to be the analogy between how far Newton's physics has gotten us now, and then quantum after that. Who knows what's after quantum, right? I was listening, at least partway this interview that Lex Friedman released with Stephen Wolfram. They're just talking about all this crazy cutting edge stuff with complexity theory and AI and consciousness and all that stuff. And I mean, we have no idea what's going to happen next, right? Like we're building the future. Literally, this is probably the only time in human history we are literally building the airplane while we're flying it. You know what I mean? So yeah, that's kind of the analogy. I think it's like, okay, well, everybody thought Newton's physics was it, and then quantum mechanics came along, and who knows what's after quantum mechanics.
I think the general trend is like faster, easier, like because people are so excited about semi-supervised learning, which I think is a little silly because it's like so obvious. Like, oh, you want to label some images, but you don't want to label 1 million of them. Maybe you should train a crappy model when you have 100 labeled. Like, it's funny because people say it's so profound. It's like, no, dummy. Like, of course you should do that. Yeah. But I think when it comes to better and faster, you can imagine some really, really brilliant, really, really good unsupervised deep learning approaches where the moment you label like 5 or 10 images, it's like just like taking off, or it's done like some pre-clustering or something. I get really excited about this concept of AI that survives to please you. And by please you, I mean actual insights. So ring.com, their camera app is awful. Like you can't turn it on because it just blasts your phone all day. That's not actual insight. So I think AI of the future, everything's actionable. Everything's
what class of deep learning do you think will take us there? I mean, it sounds most likely deep reinforcement learning. Some flavor of that will probably be huge in the future.
Yeah, I think I think there's been some excitement around novelty-based systems or focus-based learning, like, and I apologize too because I used to drown in this stuff. Like I would like choke on it. This was my life for 3 years, and I went a full year at Data Robot without programming, and now I'm programming again. coming back into the fold. I think that you're going to have deep learning networks that can be much more impressive training from zero. So GPT-3 and these big nets that train with more data than any human can ever imagine. You're going to have some deep learning examples that shock you with their ability to learn with limited observation. And when I think of those systems, I think of systems that are really good at novelty. Because right now, deep learning is not. If I throw like an outlier into the training set, it's not going to do very well when it sees a similar outlier again. And so I think you'll see deep learning systems that when they detect novelty. So I almost imagine this deep learning system. So Joe, you think this is creepy because I want to design a deep learning model where I have like eyeballs and pupils. And so I'm feeding data through it. And then when I feed it something novel, you'll see the pupils dilate like, whoa. And behind the scenes, this deep learning model is doing some very aggressive augmentation on that recent observation. It's trying to be as aggressive as it can to comprehend what is this new thing that I just experienced, where I think a lot of deep learning models today are quite dumb. Like you give it an outlier and it's not smarter for it. And so I think the deep learning systems in the future will be very, very good at quickly adapting to an outlier, even a single observation, which is what the human brain does.
If we think about, AI eventually gaining some type of cognition, right? I think language models will be instrumental to making that happen. Because if you follow Noam Chomsky's idea, his theory of language is like the fundamental aspect of cognition. That is how we think. So developing really good language models, right, could maybe help facilitate cognition within AI. What are your thoughts on that?
I worry sometimes that we're trying too hard to build up into the right, not knowing where we're going. And I really like the idea of working backwards. Like I feel like for everything in my life, working backwards is so useful. Like we've talked about value. We talked about the more you're in the head of the person at the end that matters. People want to get promoted. They want to be successful. They want to get their bonuses. The more you're in their head, the more you can work backwards to success. But for this example, you should build an AI system that can learn a language. So, Preet, I think you're exactly right. Like a language is kind of the core of it. But when I think of language, I don't think of like GPT-3. I think of an AI system in my kitchen. I just had a new baby. Just kidding, I didn't. But if I did, I have an AI system in my kitchen that is there and I'm interacting with it just like I would a child. And it begins to mimic and learn a language. And everyone on this call would say, well, just because it can mimic 20 words or 50 words like your child, it's still not there. And I think what you would see is you'd have these milestones, like 20 words through experience, 2-year-old level through experience, and even like a 7-year-old through experience. AI experts would still say this thing is not conscious. But when it goes to school and it's studying physics, now we start to feel uncomfortable.
Yeah. Joe's talking about, Ben just talked about babies. Joe's talking about one-shot learning. Just a little, anecdote here. One-shot learning in babies. Earlier this week, I dark outside in the morning time, pointed I had my son with me, looked out the window, pointed to the moon and said, moon. And he's like, moon. And now every morning since then, he's been running outside straight up to the window and saying, moon, 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 looking for the moon. Or when we're in the, backyard at nighttime, whatever, he's like looking around for the moon. So one-shot learning, like this is something that I don't know too much about. Is this something that like there's actual research into, or is this something that's just like,
the notion really is that it's more in computer vision, but you could use it to not use as many training examples and still come up with basically the same thing if you train on a bunch of images. So I think it's the notion is reduce the amount of training instances that you need.
So is this
to do the same thing?
Is there some element of like self-supervised learning in this?
I don't know. I need to go back and read the paper. I remember reading it last year, and but. It seems like I think that's kind of what Ben was hitting on too. This is because the amount of like GPT-3 consumes a ton of data and parameters, right? It's ungodly how much that uses.
Megabytes and megabytes. I think is gigabytes,
insane.
sorry, megabytes. It's many multiple tens of gigabytes large. Huge.
Yeah, but it's just a field where I'm obviously more in data engineering, but I do still kind of keep abreast of this stuff because I think it seems like a lot of the heavyweights in the field too, your Hintons and so forth, are trying to think of new ways. Like I think they feel like deep learning sort of reached kind of its limits. And I would think they'd be the ones to know, since they're the ones who kind of invented it in the first place. So, but it's hard to say where it goes. I don't know. I mean, I would say if you wanted to know, I mean, those would be as good of a place as any to start. Just look at the stuff they're putting out in publications and papers, because I'm always fascinated by that. And causal learning, that's the one everyone talks about, but I'll be interested to see where that goes. So I don't know.
Like the Bayesian belief networks type of thing.
Mhm.
Causal learning. Ben, you're about to say something. Love to hear from you. If anybody else has anything to say or ask on this topic, please do know your thoughts, inputs, questions are welcome. Ben, go for it.
I think one of the huge things that's missing from these deep learning frameworks is the ability for recall. I don't mean recall by the data science definition. I mean recall as in memory. So search is something that is, Google has search engines have search, but when you're building a deep learning model, you don't really think about its search capability. You can carve off the bottom of your classifier or right above it, and you can pull out a latent space, and you can do some clustering with that. Really cool stuff. You can do search with it too. Like ImageNet, a pre-trained ImageNet vector, you can search with it. But I think that's something, when I think of the models in the future, and I apologize for bringing this example up again, it's obviously top of mind for me. So if I think about a model just experiencing life through a camera, if I ask that model later, hey, check out this frame or check out this object, it will be much better than a human at going back in time and its experience and placing it. Yeah. So
here's something interesting. Sorry, let you finish your thought. Sorry. Apologies.
I think the last thought I had is just you're going to see a reduction in the number of times that AI has to review. Actually, I might be going past what I'm about to say, because I'm going to say the number of images that it has to review, I'm saying it's going to go down, but I don't think that's actually true, because when it comes to novelty, I think it's going to go up. So just like humans have to dream and we have to form these memories and connections, I think AI will have to do some of that too. But this experiential learning, I think that's what's missing, experiential learning, where it's like this temporal flow.
Well, that's a interesting thing, because so much of our experience is sequential, it's linear, it's one through line for our experience. So let's say there's some artificial intelligence, machine intelligence. The way they process things is not going to be necessarily sequential the way we do, because they're distributed, they're parallel, asynchronous even. That's not how human brains work. So I wonder what, of course, an entity like that today, tomorrow, yesterday, it's counting no age. Time means nothing to it.
Yeah, it doesn't know time, but I think you're gonna see some really fun behaviors of these systems that feel like they're living. They're gonna show surprise and novelty, and we'll all chuckle on this call because we know they're not living. But if I show them to my parents, like if my parents come over to my home is going to show huge interest in them the first time.
Mm-hmm.
They're very novel. It's very interested in them. It's paying attention. The camera is actually panning and tracking them while they walk through the house. It doesn't care about the kids or the dog or anything else. But then when the parents start coming more, not that interested. But then when an intruder comes, or like the house is on fire, some truly novel experience, the AI is wide awake. That's why I like the pupil dilation. So hopefully in the next 6 months, you'll see me show up some demo of some experiential based model that has pupils dilating when I throw new things into it. It's really interested in the novelty. I did want to call out something that we talk about language. There is the language of the world when you have comparisons, like size comparisons and relationships. I think this is something that deep learning could do better at. So if I turn something upside down in the frame, or if I shift something, the model that should be a novel experience. The novel, and I know people talk about this, like imagine, being able to imagine what's missing. So I think we understand the directions things will go. I just don't know if people are thinking about the right way, because we're distracted by these massive models. Can we go bigger and bigger and bigger and bigger? But I feel like they're building these air balloons in the wrong direction. They're not kind of going back to the basics of, how does my child learn anything?
Let's hear from you. Oh, you're
muted, Gina.
Yeah.
Sorry. Yeah, there we go. Better. So I don't want to take us in a way off course, but I've been seeing a lot of what I imagine is hype about quantum computing. I mean, is the fundamental issue, Ben, do you think, the algorithms, and if we just get more faster compute power, or it's just the algorithms, or do we need a fundamentally different hardware architecture? What do you think?
I don't know if quantum computing will. I think the most profound thing I heard about quantum computing is someone who's at Google now. They said it won't make our current models run faster. It will solve new problems we haven't thought of. Because I haven't done any programming to kind of understand the restrictions. There, some of the ways we approach problems might not work very efficiently on quantum computing, but I do think we're going to need an order of magnitude increase in, like, I'm a huge fan of NVIDIA up into the right, up into the right. Like their stuff keeps running faster. But I think as we get into these much smarter systems, like even when I think about like how would I design a model to react to a novel event, it I quickly begin requiring some very high compute. So I think we are going to need orders of magnitude more compute to have an AI system that is completely useful. Like I like to think of the smart home that you don't want to fire, the smart home that you don't want to delete or turn off notifications. And I think in the next 10 years, we will all have that, which will be super useful. You can actually have a conversation with your home and all of your appliances will be in total command and control. And if something's annoying you, your home will know that. Like if you're annoyed because the house is messy, and the home will quickly figure out where the mess came from. It wasn't from you, it's from a kid. And then the home will realize, well, do you want a consequence applied? I know the kids watch TV. I can disable the TV. And so you can imagine this type of interaction where you're like, well, actually, yeah. You see me yelling at the kids, no TV because the house is messy. The home just says, done, taken care of. But this wasn't like a data science heroic effort. This was just a natural conversation. The home is not living. It's not alive. Was it useful to you? Hell yeah, it was useful. You're like, take that, kids.
Like the episode of Black Mirror when a lady like has like a miniature version of herself digitized and becomes a smart home for her. It's a crazy episode. But even upstream from all the computation and all the algorithms, we don't understand how this actually works, how this experience actually works. We can't even model a paramecium or a rose. Much less a human brain or single neuron. We can model a single neuron. That's what deep learning kind of does, but it's a tough problem. Antonio says that he'd go to Ben Taylor University, campus location, Utah Mountains.
Nice, thanks. Like my brain spins out of control thinking about, in a good way, thinking about the smart home, because like how many of us have left our garage open? We're like, darn it, dang it, I don't want that open. And your home would very naturally, like I would actually like a smart home that just starts closing it for me. Like it figures out rules, and if it closes it too soon and it notices I don't like that, it adapts like a controller. But you can imagine a smart home that just, it escalates into like a queue of potential automation tasks. Would you like me to close your garage when it's been open longer than 10 minutes? I didn't ask for it. It's just been learning and it thinks that's useful. Or like, would you like me to, I notice you have a fitness routine. Would you like me to hold you accountable to that? And what I'm saying is, I'm not forcing you guys to be held accountable to that. But for me, I might have my own life where I'm like, yeah, hold me accountable to that. And then so those types of interactions, I think they're limitless. Like we could come up with 50 ideas where we would all agree, yeah, that makes your life better, but those ideas are specific to you. And that's something I get super excited about.
So for a use case like that, like just exactly what you just described, where are the current limitations falling short? Because I feel like that's something that deep learning could probably solve that, like for sure.
I think the thing that's falling short is, if I wanted to be critical, I won't call it experimental AI. I'll call it brittle AI. That's where people approach problems with horse blinders on, and they're so focused on like elderly slip and fall. I see you fall. A better way to think about it is anomaly detection, or like all the data that matters. So all these systems, they shouldn't just be consuming video. What time of day is it? What are all the features going on? Like how many people are in the frame? Like they will have so much data, but this doesn't mean it has to stream up to Amazon where you feel violated with a privacy concern. Like even today, like I've got this AI system, and my 7-year-old was like naked in the living room, and like that's captured in the TV. I'm like, and my reaction's like, what the hell? Like, why are you naked? Like, why are you naked down here? He's just like on his tablet. But like I don't want that information leaving my home, but that information can be processed by an AI system. Like, like can you guys might think this is dystopian or like this is a future you don't want, but imagine the AI house saying, "Get your pants back on." Like it's the main floor, it's my kid, he's butt naked, get your pants back on. Your father's coming, get your pants back on. And the kid is like, no. And then the AI system turns off his tablet. He's like, I hate you. I'll go get my pants on. Um, I don't know. I might be too obsessed about this stuff. You guys might start to wonder, like, does this impact childhood development if the rule enforcer is not a human? And I'm sure it does. I'm sure there's some impact there, but whether it's good or bad is unknown, I think.
I mean, that's something for you budding psychologists, behavior psychologists out there to test that out. I think that'd be interesting. Like, to test out. I feel bad for those kids if it fucks them up, but
well, I just want the laser system that kills fruit flies. Like if it ever sees a fruit fly in my kitchen,
Yes.
it'll be like game over, no humans. And but you'd have to have super high trust because no one wants to go blind walking to their kitchen. But even just like imagine an AI system that prioritized what order you ate your food. You know, the bananas are going to go bad in 3 days. Like the AI system already knows that, and it's telling you what you're going to eat for lunch. And it's like, well, you like this, sort of, but if you don't eat this, you're going to waste a lot of food. So it's like it's trying to optimize. It's like it reminds me of like the traveling salesman problem. It's trying to like optimize like this mixed bag of suboptimal lunches or like breakfast. And if you haven't gone shopping to the store, then your lunch options are going to get really shitty where it's combining like the worst possible combinations. And you're like, I can't eat this. And your home is saying, I know, but you need to go to the store. I already ordered the pickup because I knew you'd be angry. And it's available today at 3. I looked at your calendar and you're available.
Gina, go for it.
So, okay, so I'm off mute. Now I put my hand down. There we go. Yeah, so not to interrupt the kind of meta or larger cognitive questions, computing questions, model questions, algorithm questions, more practical matter, because you mentioned Amazon and stuff going up to the cloud, et cetera, et cetera. So while you guys were talking earlier, I was on the one hand thinking quantum computing, and the other hand, I'm thinking IoT, small devices, models on a chip. And I've heard of, this being a thing, especially with sensors, and actually also, I mean, probably in a range of areas, but for example, in environmental monitoring, if you have sensors deployed, way out in the field someplace, obviously, you're not going to have, a workstation or something, or any number of other sensors out in the real world. You're going to need a really fast response from that sensor to do something. So does that, I don't know if that factors into your thinking at all, Ben. I mean, you're talking about something that's a lot bigger. I'm not saying that some small device is going to do all these things, but maybe there's some kind of integration there with the hardware and the algorithms and so on and so forth.
So Gina, I think you're exactly right. The way I think about it is all of this inference actually happens on the edge. So you have edge sensors because it's actually too much data. So if you have 50 cameras in your home that are streaming 8K resolution, you actually don't want that to go anywhere really, like, because that's just a ton of data. So you want edge devices that are deciding if things are actionable, and then like routers, they are escalating them to the main hub, and the main hub is what is sentient, or like some people think it's sentient, it's making decisions. There is an evolution too. Like you have NVIDIA and companies like that that are trying to make certain AI models run faster. They're trying to change some chip architecture, but the ultimate is to actually make custom silica, where you're saying, hey, for this particular use case, we will actually engineer this entire chip. It's actually incredibly limited. Like it can only handle this type of video input. It can only do this task. You have no option to program it. And so I think when you get there, then we will be very happy with some of the power consumption, because everything I'm describing, if I have to run that with all these like edge GPUs, even with Jetsons, you're like, okay, like that's actually showing up on your power bill now, like doing all this massive inference, and your house is a little hotter because of it all. So I think you're exactly right. I think we will get there where you have very specific purpose built. One of the things that surprised me is how easy it is to roll out a new chip, because you have like these global foundries. So someone on this call, like if you had funding, if you had, I'm not sure what the number is. The numbers keep coming down. Like, is it 50 million or 10 million to develop? You don't have to have a fab. You can actually just say, this is what I do. This is the chip architecture. You pay some consultants. They go send it out to TSMC in Taiwan. And here's your chipset that you can like start deving on. Like, look at companies like Tesla. Like, they don't have a fab, but they can get these chips made. That's something that's always blown my mind. Like, what humans on Earth design chips? Like, I would look at these NAND flash chips and they look like cities. You zoom in on like a scanning electron microscope and it's like New York, but probably much more complicated. And there's some human somewhere that understands all of, they can explain all of it, which I always thought that was insanity. Deep learning is so easy compared to that.
My brother-in-law works at Apple. He designs the chips there. So he does like chip design and chip speed testing. It's insane, man. I don't know how the hell he does it. He studied electrical engineering.
That is nutty.
Yeah. Speaking of silicon, man, the M1 is insane. I was running 20 iterations of Bayesian search on my M1 on a 4 million row data set. He's using variation of light GBM.
Speaking of silica,
Ooh,
here's some NAND flash.
Nice.
wow. It's got a wafer there.
Yeah. Sad I cracked it. This is my good job, Ben. We're proud of you, wafer.
That's like 12. Is that a 12-inch wafer?
300 millimeter. So I think,
Yeah.
is that 12 inches?
Probably.
I think it's 12 inches.
I don't know if they're all 12 inches nowadays, or if for smaller applications they're doing, like they're still using the equipment to make smaller wafers. It's been a while since I was knowledgeable in this area, but yeah,
They're
I
all
love
about
those.
scale. So I think 350 millimeter was the norm when I was there. I think they're pushing for 400 or 450. Like the bigger they can make the wafers, the more. It's so funny because people get so excited about like, oh, the chips are getting smaller. Everyone wants to make them smaller, but the economics are they cost less chemicals to make, and so smaller is a bonus. So I always thought that was funny because I thought, I'm so happy they make a terabyte micro SD, but the reality is like, yeah, it just took the economics make sense. So they will always go smaller because it's less chemicals and material to make it. But now they're at like the electron limit where everything's super problematic now because they're less than 10 nanometers and you count the electrons in your memory cell.
We're just getting started with all this stuff. We are at the beginning of infinity with everything. We are really at the beginning of infinity, my friends. Let's go ahead and wrap it up, man. Thank you guys so much for hanging out, Ben. Thanks for bringing on the interesting discussion. Really enjoyed that. You should listen to the interview I did. Everybody, if you're tuning in, it's not released on the podcast yet, but it's live on YouTube. The interview I did with Marcus Du Sotoy. He's an Oxford professor. He wrote the Creativity Code. I love that conversation. Like, we talked a lot of philosophy of mathematics and things like that. So definitely tune into that. Spoke to the people's data scientist himself, Danny Ma, yesterday. That is on YouTube as well, but it'll be dropped later on the podcast. Shout out to everybody that joined in on LinkedIn. Antonio, Greg, good to see you guys there. Shout out to everybody that came in today. Be sure to tune into the interview I released today with Andy Hunt, author of The Pragmatic Programmer, legendary author of Pragmatic Programmer. It's a great conversation as well. What else? We got a bunch of really interesting episodes coming up. If you guys don't mind, let me just tell you what's happening in the next few weeks. In the next few weeks, who do I got? I got interviews coming up with, let's see here. I've got, next week, I'm talking to Christina Di Giacomo. She is a industrial philosopher, so that's gonna be great. November 12th, got the episode with George Farrakhan. November 19th, Steve Carindale talking about turning ideas into gold. November 26th, talking to Korush Alizada. We talk about NLP and philosophy. Then December 3rd, Christian Espinoza. We talk about why you shouldn't be the smartest person in the room. Then on December 10th, talking to Dana McKenzie, who's co-author of the Book of Why. So we get a good conversation there. So hopefully you guys get a chance to tune in. And if you haven't had enough of me this month, realize that there are about 193 episodes published. That's over, probably 300-400 hours of content at this point. We're just 5,000 downloads away from 100,000 downloads. So if you haven't listened to any podcasts from the Artists of Data Science, go make up for that. Help us crush that 100K. Took a little over a year and a half to get this far. Hopefully we get there by the end of the year. I would love to see that happen. You guys take care. Have a good rest of the evening. Happy Halloween to everyone. Thanks for coming by. Remember, my friends, you got one life on this planet. Why not try to do something big? Cheers, everyone.
Thank you. See you, everyone.